streaming. Oh. Yes. Yes. All right. I mean, it was a joke because I was convinced of being streaming and I wasn't. So now I will have to bore the people in the class. That will take time to do the other exercise, right? The one of the covariance, and repeat to the people at home what I've just done. So the very first thing that we have seen was the predicate, and there was a thing that provoked some headache beside the copying the wrong function. That was like here we had just written 0, right? Then the problem with writing 0 is that the compiler wasn't smart enough and then was getting confused. Technically, what we are doing is that we are creating a predicate that should operate on a vector defined on an arbitrary field. Now, field could be complex, could be dual values, could be scalars, could be float, double, whatever. Now, in order to return the predicate, we were not returning a distance or something like which is more articulated. We were comparing the result with this expression with 0. The compiler wasn't smart enough to understand what was the nature of this 0. And therefore, additionally, should we construct a plain sight predicate on a tree, for instance, consisting of dual values, because we want to do something fancy? Well, 0 is not a valid initializer for a generic scalar type. So we would like to do something like that. Get from the vector type the type of its field. To this extent, we could just using. Can we extract it from the vector type? Yes, of course. Using vector type, using scalar type equals vector type scalar. Why so? Because into the Eigen types, there is a defined inside the using, which is scalar, which is the scalar that you pass into the template. When you do matrix float, the using of that matrix, the using named scalar of the matrix will be float. If you do matrix double, the scalar in the matrix will be double. Okay, and then here we would have to do scalar type 0. This is just like make it simple. If scalar type is float, then here you will see float of 0. Okay, guys? That was the problem that was in the solution but not in the implementation. That was tricky. Now, the compiler is not smart enough to understand that this is a type, so you have to help it and write type name. In general, you have to write type name in front of every nested type that you extract from a template to tell, hey, man, this is really a type. Okay? And then here we could write the scalar type. Now, if I run this test, hopefully it compiles, yes. Do I have people? I have people. If I run this test, I can predicate P is my set of points. I expect, actually, like I modified for your colleagues the code, so I just recover it, 0, 1. We expect to see all the points which have, I have also to compile it. All the points which have a positive z in front, and then once the points, and this is all the points which have a positive z, and then once the first point with the negative z begins, then all other points should be bit points with the negative z. So this means that we split the set in two. On the one side we have the points with the positive z, on the other side we have the points with the negative z, right? Because we cut through a plane. Just like I also demonstrated to your colleagues, the possibility of having splitting, for instance, on a plane which is parallel to the YZ plane, therefore that has a normal oriented along the X, and then let's see what happens. What we expect is that we will have all the points with a negative X with a positive X coordinate at the beginning, and all the points with a negative X coordinate at the end. Okay? This was the first thing that I did. Then the second thing that I did, and so that basically concludes the exercise. The second thing that I did, you might see how we are composing the things, right? We are basically putting together the split and the predicate that divides the things on a plane. We didn't rewrite the split. We used the split of before. And it works on every arbitrary vector. Then the second exercise, which was like the sort, Eigen transform sort. The second exercise, well, you might see that at the beginning to simplify, so was requested that you were loading all the points in a file into a data structure, into a container, that you were constructing another container where you were applying a transform that was user specified through x, y, z, alpha x, alpha y, alpha z, to each of the points in the container, and then to put these points in another container, right? And then at the very end, you were required to complete a predicate, which was templatized by the index, that was sorting the points according to the index that was specified on creation. Now, I've been a nice person and I offered you the three rotation matrices along the x, the y, and the z, as you see them in robotics. You read in line because I just like said, this function is so small that can be expanded whenever it's used. I hope you don't have any doubt in that. What I do, I calculate sinus or cosinus, I allocate a matrix, I fill in the matrix, and I return the matrix itself. And then here was the coordinate compare that now you see the solution, but before it was like that. Now, this is a comparison predicate. So being a comparison predicate, it should take two arguments, the first and the second vector, right? Here I restricted to vector 3f because in the text I specified that the vectors have 3 coordinates. So I have to write a predicate. This is a function object, so it will return a bool. Why do you say const vector 3f ampersand? Because if I would write this way, I would have a copy. If I don't write this way, I don't have a copy. And I say const because I don't want to change a and b. And what will I have to return? Return a in x smaller than b in x. And then, following what we have seen last time, where we created, let's say this way, variable version of the comparison operator that stored the variable. In this case, we define the index when creating the comparison operator through the template. And the exercise mimics the one of the last time. So now we can go through the main. The first part will just read the parameters from the command line and put it into alpha x, alpha y, alpha z, tx, ty, tz. It will print the red rotation and red translation. The last element, argv of 7, is going to be the file. If you supply less than 7 arguments, it's going to say no, the program, and will not function, because at the beginning I do a check. If you have less than 8 arguments, say no. Then we create a container of points. We load the points. We say how many points we loaded with some space. And then we construct, this was the interesting bit, we construct an isometry. The isometry is the transformation that has a linear part, the rotation matrix, and a translation part, which is the vector. We assign to the linear part isometry 3f, means because it's 3-dimensional. There are also isometries on the plane, which is isometry 2f, and where the rotation matrix will be 2 by 2, and the translation vector will be 2 by 2. Then we populate the linear part, we populate the translation part. The linear part is populated, yes, I do have people. The linear part is populated by multiplying the three matrices according to the angles as we read them from the file. And then we have fun, we construct a new vector, we call it transform points, and given that we want to be gentle with our computer, we pre-allocate the vector on construction so that we don't have to make it every time wider and wider and wider, stimulating the heap in an unpleasant way. And then we iterate through the points, and that's the nice tiny bit that you can calculate the ith point from the ith destination point from the ith source point by multiplying it by a transformation matrix that is consistent with what we normally do. Then we enter in an endless loop that is the sort that will ask the user, do you want X, Y, or Z? And then depending on the X, Y, or Z, we call the source method of the standard library, supplying the initial and the final iterator, and supplying the comparison comparison predicate instantiated in a template fashion to the index that we want to have. That clear? And that resolved the second exercise. Then the final thing that we were doing, we were printing the points. I could have also used the save points on Cout. All right, let me use save points. Points. Chave. Okay, that's equivalent. Instead of the for loop, we called our function, we save the points on the standard output, and that's equivalent to iterating through all points and printing each point individually. Let's see if it works. Eigen predicate, those are eigen transform points. Transform sort, geez. Okay, now, what am I gonna do? I'm just translating the points for simplicity. Or, yeah. So, 0, 0, 100, 0, 0, 0, and P. Okay, now I just shifted the points of 100 units on the z-axis. So I expect that all the z-axis of the input points that were in the range -1, 1 will be added of 100. And then I want to sort them on the z. And that's exactly what I see. First of all, they are sorted on the z, and then all the points are 100 plus -1. I could apply, I could do the same and, for instance, apply a little rotation. 0, 0. Now, specular rotation, pi. 1.57. Well, I would like to, because I have to express the angle in radians. Okay. Okay. Let's try to apply a rotation of 90 degrees on the z-axis. No, what's the other one? 0, 0, 0, 1 point, no, I didn't save it, 1.57. Okay, now you see the transformation matrix. What I'm doing, interesting, is also to show the isometry to the user. And this isometry is clearly a isometry that expresses a rotation along the z-axis that stays constant, and here you have -1, 1 that expresses the change between the x and y axis that you see when you have a rotation of 90 degrees. Okay, and this is the isometry, this is the rotation matrix that you constructed, and the translation vector is 0, 0, 0. And the last line you ignore, basically, because you're not looking at it in this course. Okay? Clear? And then we can sort in the x, in the y, in the z. Exercise over. See if there are questions. There are no questions, and I go on. So this exercise was doable. I want a feedback. Was it doable? If once I show it, yes, right? But before? Boo. Silence, pain. At least, did you understand? Do you see the solution? Do you understand the solution, guys? Okay. Because, I mean, a lot of things, of course, I do them, also the type name. A lot of things, they come out while doing them, right? So don't get scared. I mean, the only thing I can do is to provide you with examples and with reasons why certain things should be done in a way or in another. And then your experience, once you will be doing, will build on that. Okay? All right. Last thing, covariance. All right. Boom. This was disgusting, this template. I mean, let me shrink the font. Do you see this way? Can you see enough? Okay, now, let's reason on what was I asking. I was asking, I give you a begin and an end of a set, of a container. The begin and the end. I tell you that this container is going to contain points of fixed size. That clear? And I would like you to return, to calculate on this set, the mean and the covariance, according to the formulas that I have given you before. Okay? Now, the problem is that every information is contained in the iterator. From the iterator, you could access to the contained type, which is a vector. From the vector, you could access to the number of rows of the vector, to the number of columns of the vector, and to the scalar of the vector. And these elements are those that are necessary in order to calculate the type of the result, where the type of the result is going to be a vector equal to the vectors contained in the set for the mean, and a matrix defined on the field stored in the vector having number of rows times number of no rows elements storing the covariance matrix. And then this horrible thing here, this horrible definition comes out. So our function will need to have four arguments. The first argument is the reference where to write the mean. The second argument is the reference where to write the covariance. The third argument is the begin iterator. And the last argument is the end iterator. Okay? Now, unfortunately, between here and the definition of the method, I do not have the possibility of defining usings because the template starts immediately here. Right? That's terrible. That's our problem. So I have to expand everything, and then you see how painful it is. But here I'm simply saying, there is the iterator. The iterator has a value type, and the value type has a scalar, so I am able to figure out whether the mean is a float, a float vector, a double vector, a dual value vector, or what is the field of this thing. And so the first argument will be an Eigen matrix defined on a scalar field, which is this. So extract from the iterator the value and the scalar, and then tell it that it's a type. And that has a number of rows, which is equal to the number of rows stored in the value type of the iterator, rows at compile time. So if you pass a vector dimension 3, these rows at compile time, this constant will be 3. And then one column. And that's going to be the mean. The second element is going to be the covariance. That has a number of rows equal to the number of columns, which is equal to the input. And then you have the two iterators. Of course, this part is what I was filling you ahead, because it would have given, pain in your guts. All what you were required to do is to fill in this thing here, right? Let's do it in the naive way. For we calculated the mean. We start from the start. We need to copy the begin, because otherwise when we construct the covariance, we would have taken the begin to the end, right? So we copy the iterator underscore start. And we create a new element, a new pointer to the beginning. Int count equals to 0. Equals count equals to 0. And then until we don't reach the end, we accumulate the values in the mean. Clear? Or not? Now I leave you 3 minutes to calculate the covariance. Observe, even if it's ugly, this business over here, I'm returning, once I invoke this method, I need to pass to this function, I need to pass to the function a variable where the function itself will write the mean, because I'm returning 2 arguments, I'm not returning 1 single argument, and so I can't return it through the function as it was. Clear? Clear or not? Okay. In C++, you can't return tuples. Now, here, this function takes 2 inputs, the begin and the end, and returns 2 outputs, the mean and the covariance. Now, how can I return 2 outputs? I could define a struct containing a mean and a covariance and return it, method class number 1. Is it necessary? Both. I didn't want. I have another alternative. Is that I pass to the computer the address of a variable where it will write the result. So I'm passing the address of a variable that will contain the mean, and I'm passing the address of a variable that will contain the covariance. But instead of passing a pointer, I pass it a reference with the ampersand. That clear? Now there is a faster method to calculate the covariance that doesn't require the double iteration, which you can find it in the slides. But it's like, we can also live with that. Eccolo.
I don't understand how to calculate mean. How to calculate mean.
We take this argument over here, right? The mean. It's a vector. We set it to 0. No? And then we have the start, the begin, and the end, which is my start and end iterator. What we do is given that we also need to do another pass in the set, if we would take begin and increment begin until the end, when we need to calculate the covariance, begin would be already at the end, and we wouldn't be able to calculate the covariance. So I make a copy and I say, okay, define a new iterator, call it start, and set it equal to begin. Clear? Then remember that we have also to count the elements, right? So we count. We declare a counter, and then while the start is different from the end, you take the mean, and this is a plus equal, you sum to the mean the value pointed by start, right? And sum. You increment the iterator, and you increment the number of points that you have accumulated. Is that clear? And then at the end, you take the mean, and you divide it by what? Remember the game. We would have to divide it by count, right? The problem is that the problem that we have encountered before. Count is an integer. Maybe the system will mess up, so I want to create a type that has the same field of the field contained in the matrix, and then assign to this type, convert count to this type. Tell me when one has finished the... You don't count, Omar. When one is done with the covariance, before me starting. At least two has to have done it, or has to have some issues before I start. Let's see if someone is writing to me. By the way, Omar, do you have the laptop on? Did you do the exercise already, everything before? Right. So, like, can you monitor the chat and answer the people that, if someone has questions? Because I can't do the two things. You need the few, I have the laptop for you, by the way. Yeah. At home. No, my maschero. I will mask myself. No, it's disturbed. Yeah, exactly. Every lesson reads from the previous one. So I'd rather slow down, but I need to receive feedback from you to slow down, because otherwise it's not. Like when I drive, I don't look at that. I'd rather slow down rather than, but you have to be compliant, rather than going on too fast and losing people. I mean, to which lesson are you, honestly, how many episodes did you lose because maybe there were other courses?
No, I am following all the lessons, but there are still some things that I have to figure out by myself. As you were saying, when you do this stuff, you are not able to face the other. Maybe.
But it was not directed to you. It was a general question.
Yeah. Like for me, for example, is the fact maybe I'm not used to templates, for example. But in order to understand, I can follow the lesson, the subject, but I will understand better when I program.
Yeah.
So I'm just looking at the exercise for this reason.
For the last episode. Okay.
The last lesson.
Exactly. So my question is like, because I need to know how. I mean, it's normal during the course of study of everyone to be 1-2 lessons behind. This is normal. We all do, especially now that there are the recordings and everything, and one can say I can catch up whenever I want. For me to understand is. How many lessons or exercises are you behind in general? 1, 2, 3. Every one of you says a number. We are behind 1 week, 2 weeks. I just need to know. It's not an evaluation. So you are behind 1 week because you're doing the exercise of last week. Yes. How many? You? 1 week. 1 week. So how many people that are behind of 1 week? I want to see your armpits. Okay, half the class is behind of 1 week because you have lost the Thursday lesson. So, okay, now I will go on with the lesson, but I mean, honestly speaking, it's poorly efficient that you come to the lesson and you see the lesson without having seen the previous lesson, because it's going to only confuse you if it requires to do the exercise. You know what I mean? With this, I'm not saying not to come because I need feedback. But in terms of you, don't suffer too much if you don't understand these things, because a lot of stuff, or if you struggle, because a lot of stuff has been taught in the last episode. And if by reading or watching the last episode you don't have, there is something unclear, then it's my fault and you ask me questions. That's what I want. It's about the emotions. Don't feel that it's bad. It's just like that every lesson builds to the next, to the previous one. And yeah, that's bad and it's good. So, but of those that are on par, so who is aligned with the lessons? Show the armpits. 3. Don't be shy. You will not be bullied. Okay. 4 people.
I am aligned with the lessons, but on the exercises that's the struggle.
Well, that's the game.
I haven't done the last one.
I
followed your lessons.
The exercises.
These exercises, I haven't done the last one since I've done it looking to your lessons.
I see.
Doing it.
You didn't try yourself,
Exactly.
and so you didn't experience the pain.
Exactly.
I understand.
Because there wasn't enough time. I mean, there was on Thursday.
Yeah. I understand. Was simultaneous. I understand. Well, I mean, so of you, do you manage to catch up with this? So, how many did the covariance of the 4 that?
It's not
right?
working well.
Yeah. Getting there.
Yeah.
No, it's.
You come here.
Yes, I'm coming. No, because I need to calibrate on those that, you know, on the number of lessons. L'ha fatta,
L'ho fatta, mi questo errore, non riesco a...
Iterator type, using iterator type, because this is not a type, è un tipo. È un row set compile time, è un intero. Cos'è questo? Cosa vuol dire? Vuol dire, prendi l'iteratore. L'iteratore ha al suo interno una using, perché so the iterator inside has a using called value type that stores the type that you access to the directors. And then out of it, this is a vector. È un container. It's a container. The container has iterators. The iterator has an object that you access when you do start. L'iteratore è iterator type. È iterator, io lo dici. L'iteratore, the iterator has a type inside, right? And this type is going to be the type that you have in the vector, in the matrix, in whatever it is, that you have in the iterator, right? And this type is accessed to the using value type. Okay? So now, if you have an iterator of a vector, of an array, of a vector of vector 3f, value type is going to be a vector 3. Now, you would like to know how many rows the vector 3f has. And this is a constant. It's not a type, it's an integer. So, and also using is wrong, because using is a type alias. Is a type alias, right? Esatto. Tu vuoi definire un iteratore che è all'inizio, che può fare?
Ma cosa articolare?
No.
Using scala.
Scala.
Sopra. Questo lo dico io.
I mean, the using scalar, it was only for clarity that I put the using scalar on top. I said, here I want to do, I want to be a decent person, and I want to extract the scalar, right? Like I just said, this is only for clarity. The game of this template function is to extract from the types of that you passed in the template all possible information. And what are the information that I need here? I need to know the dimensions, and I also need to know the type of the field, the type stored inside the vector. Understood? It's a float. And what I'm doing is like, okay, let's call this type scalar and extract it, take the iterator. From the iterator, extract the type of the object, vector 3f, and from the type of the object, extract the type of the scalar. Okay? So this is going to be float, or double if you have a vector 3 of double, or int if you have a vector 3 of int. Understood? Clear? And that's the type name. The other one, rows at compile time, is an integer. Rows at compile time is the integer that you pass when you do matrix 3, 4, right? Rows at compile time of matrix 3, 4, float 3, 4 is 3. Columns at compile time of matrix 3, 4 is 4. But it's a constant, and as a constant is attached to the type, not to the instance. Let's compute the covariance, come on. Isn't it nicer? First thing, we have to restart from the beginning. Then we need to, I don't like to calculate it twice, even if the compiler is smart enough that does common subexpression elimination and it's going to remove the expression. But start minus mean, and then cov plus equal times.
Count is the same of the mean.
Just to be consistent with that. Or you could also use do the whole soup in once. Alternative, even if I dislike it a bit, could have written all the long story. Oh! This is another alternative, no, to this one. Observe what I've done here. Given that I don't like to have extra long type names, type defs and so on, I just said, okay, now I'm inside the body of the function, I feel like all relieved. And so, because I can use the using, I take the iterator and I extract from the iterator the type of the point, vector 3f, vector 2f, or whatever. And so, I have the first business. Then, from the type of the point, I extract the type of the scalar. Okay? Understood? And you need type name because it's a nested type. And then I start doing my calculations. Interestingly, this works for every size of vectors and every size of, vector 3f, vector 10, 20, 100 components is going to work. And then the last one, you will use it, but you will not, no, it's nothing spectacular. You know that the covariance is a symmetric matrix. Symmetric matrices admit an eigenvalue decomposition, no? From linear algebra 1. And then Eigen provides you with a way to calculate the eigenvalues and the eigenvectors of a symmetric matrix. Okay? And then this method over here, trivially, like you give it a matrix and it returns you the eigenvector that corresponds to the largest eigenvalue. Okay? Here you have eigenvalues, you have eigenvectors. That's what it does. But it does it doing some calculations inside Eigen. This is just given by me, and we will use it in a while. Okay, guys? This was an alternative. Do you have questions? Is it all clear? Sorry? Sorry? Yes. Your colleague says, isn't there a need to increase the start? And the answer is totally yes. Yes, we need to increase the start. Okay? Like otherwise, the start, this would have led to an endless loop because the start was always there, bam, 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 and it was never moving. Okay, this is, let me put this because I like it more. And this is one possible implementation of the covariance. There is another one which is a little bit more efficient that I don't have the Blackboard to explain, but normally you calculate the efficient variant would be something like that, I think. Point type, parallelly const x per int. Now here we have extracted the dimension from the point type, so we could just trivially define a matrix. No? This is the type of my covariance matrix. Do you agree with me? I take the vector and I tell it how many rows do you have at compile time. I also say that this should be dim. And then therefore, this is the type of my covariance matrix. So this and these are completely equivalent. No, this and this are completely equivalent. So mean covariance, where is it? Mean matrix, yes. These and these are completely equivalent. And the point is that it's incredibly long and it provokes pain. Yes. This is the matrix. This is the scalar. This is the rows. And this is the columns. What we have done here is simply to split it into little usings, right? Like the first trip is that we get the type of the point from the iterator. The second thing is that we get the type of the scalar from the point. The third thing is that we get the dimension from the point. And the third thing is that we define a matrix, which is going to be the matrix type, by declaring it an eigenmatrix defined over a field scalar of the type that you have extracted before, having dimension. Clear? This is much more readable, much more digestible. Now, I think that the way of calculating the covariance, I have it written in the slide, but simply you could do and then sum plus equals start times it's evil start dot transpose, and then how was it? And then the covariance is equal to the sum divided by count minus the mean. Sum divided by scalar of count minus the mean. Mean times mean transpose. This is basically the way of calculating the covariance fast. Okay? But this was just for completeness that I have said it. So, just ignore, and we stay with this implementation. And this basically concludes the collection of exercises of this time. So now, depending on your condition, I could introduce the next lesson, just introducing it. It's just talkative, okay? And then next time we will see the implementation. I invite you to have a look at the implementation in this time, because there will be next time I will explain the implementation of what I will talk in theory now, and we will do funny exercises, okay? Are you fit? A bit? Stoned? Come on. No, you're dead. You dead? How dead are you? Between 1 and 10? 7? 7. So, 7.5, right? Okay, then I stop here. And if there are questions, just like shuffle them in the chat. If there are no questions, so then next time we will see the credit. As I said, just you stop me. The important thing is that you catch up over the next days. Okay?